The instant class is designed to represent only a point in time, or a timestamp. Internally, it stores a value in seconds and nanoseconds from the fixed epoch time of 1970-01-01Z. As such, an instant can't be formatted as a date or time without providing time zone information. When printed, Z is used as the suffix to indicate this timestamp is in reference to UTC. This allows for comparisons regardless of time zones or operating systems, which is why it's an effective timestamp. I'll again be using the More Time project from the last video, and we'll pick up where I left off. I can use an instant with a time zone to examine daylight savings rules. I'll show you that next, since I created an instant variable in the last video. First, I'll set up an enhanced for loop of a couple of zone IDs, one for Sydney, Australia, one for Paris, Europe, and one for New York, America. Next, I want to set up a date time formatter. In this case, I'll use of pattern. I'll pass a string literal containing Z colon and a set of 4 Zs, which outputs the time zone for a date. I'll print that out. I'll indent the next 3 lines with a tab. I'll create a zone date time by calling @zone with the zone loop variable Z. In this case, I just want to print that along with my zone format. Next, I'll get the rules from the zone by calling getRules and chain a call to get daylight savings, passing it my instant variable. There's also a method called isDaylightSavings that I can pass that the same instant, so I'll do that. Running this code, you can see that each of these zones has daylight savings rules. Depending on when you run this, the next line that's printed after each daylight savings code and name is in the format of a duration. This means it starts with PT, which stands for period of time, followed by a numeric value and the time unit used for the duration. This might be 0S for 0 seconds, meaning the time will be the same as the UTC offset. It might be 1H, meaning the time will be offset by 1 hour because of daylight savings time. This will only get offset if the flag is daylight savings is set to true. Again, depending on when you run this, this may change for each zone. When Sydney has its daylight savings equal to false, generally Paris and New York zones are true and vice versa. Next, let's imagine for a moment that our country's government maintains a database of new births, and these birth dates are stored as strings output from instant timestamps. Let's say you want to order a birth certificate with the local date and time on it for the place of birth. First, you can create an instant by passing a string. For the instant class, there's only one version of parse, so your string must be in the default output format. This has to be a valid instant in UTC. It's parsed using datetimeformatter.iso instant, so I'll enter that in. You can turn an instant into a local datetime using the ofInstant method. I'll create a local variable DOB, a local datetime. I'll use the ofInstant method on local datetime, passing my instant variable and the system default time zone, which I changed in the previous video to be Los Angeles. I'll print this out using datetimeformatter.ofLocalized datetime, passing it formatstyle.medium. Running this code. I can see that this child's date of birth was January 1st of 2020 at a minute after midnight local time, or 12:01 AM. Now let's say you're living in LA, but your child was born in Sydney, Australia, and you want to always associate that place with your child's birth date. A zone datetime class allows you to do just that. Its fields are a local datetime and zone ID. I'll create a zoned datetime variable, calling it DOB Sydney, and set that to zone datetime.ofInstant. I'll again pass this to the DOB instant, but we'll pass the Australia Sydney time zone this time, and print that out the same way I did previously. In Sydney, your child was born at 7 PM on the first day of January. As such, in Australia, your baby probably wasn't ever going to be considered as the first baby of the new year, as he or she might have been if born in LA at that exact same instance. You can use a zoned date time to get another zoned date time in a different time zone. Here I'll create another variable DOB here, and I'll assign that the result of calling the method with zone same instant on the DOB Sydney variable. I'll pass that the system default zone and print that out. This prints the same information as the DOB variable. The only difference between DOB and this DOB here variable is that DOB here is carrying around the zone used to create it. Depending on your use case, that might be useful. I covered the with method when I covered local date time, which had two arguments, a temporal field and a long. In addition to this method, there's another very useful overloaded version that uses what's called a temporal adjuster. Let's imagine that we want to know when the first day of the next month is, starting with today. Turns out there's a predefined temporal adjuster to do just that. I'll start with a variable called first of month, a zone date time, and give that the value from calling the now method on that class. I'll adjust that value with the with method, but instead of passing a temporal field along with a value, I'm going to pass it the result of calling a static method, first day of next month, on the temporal adjusters class. I'll use printf to print this date out, printing just the date part out. So %t and capital D will give me that, passing the first of month variable to that. If I run this, I get a date that's the first of the next month. If you control click on the temporal adjusters class, IntelliJ opens that code in a tab. I want to open an extra view in IntelliJ called the structure view. I'm not sure if I've shown this to you before, but this is especially helpful when you're working with complex classes or classes that have a lot of methods. I'll select View from the menu bar. I'll select Tool Windows next, and then Structure. This displays the structure view in the pane that's usually the project pane. You can see now I have tabs on the left here which let me switch between project and structure. I'm going to scroll to the top of this window. You can easily view all the static methods available to you on this class, which you can use to get a specific adjustment to the current time. You can use these methods for use cases like get next Wednesday or get the last day of this month as examples. There's another class similar to zone date time called offset date time that just has the UTC offset and the local date time. There's also an offset time, which is local time joined with an offset. Neither of these two classes uses daylight savings rules. Next, I want to look at temporal amounts a little closer, which is what you get when you use durations and periods. I've said before that periods are date-based, meaning related to years, months and days. I'll create a new variable of type period called time passed and assign that the result of calling a static method between on the period class. I want to compare the epoch date, a static field on local date, and my DOB variable's local date, which I can get by calling to local date on that variable. I'll print that period out. Running this code, you can see I get P50Y. The P stands for period, and 50Y is 50 years. This child's birth date and time is exactly 50 years since the epoch date. I'll do something similar, creating a duration. I'll call that time since, and it will contain the result of calling duration dot between. I'll pass this the instant epoch, and the instant I get from my DOB variable using a call to instant with the UTC offset. I'll pass the constant zone offset dot UTC to that, and I'll print this out, running this code. I'll now see how much time has passed since the epoch time and this child's birth. Here again, it starts with a P, but it's PT this time for period of time. And now I've got elapsed time in hours and minutes. 438,288 hours have passed, and 1 minute between the birth of this child and epoch time. Let's say there's a second child now. I'll create a new local date time variable called DOB2. This child will be born 2 years, 4 months, 4 days, 7 hours, 14 minutes, and 37 seconds later than the first child. I can chain the plus methods since each returns a new instance, and I'll do that here. I'll assign it the value from calling DOB.plusYears passing 2 and chain a call to plus months passing 4. I'll chain a call to plus days passing 4, plus hours passing 7 and plus minutes passing 14, and finish with a chained call to plus seconds passing 37. I'll copy the lines from the yours kid's birth date println statement down to the time since variable println statement and paste that at the end of this method. I'll delete the first of month code because we don't need it. I'll just add second in front of kid in the output, and I'll change DOB here to DOB2. For the period declaration, I'll change my variable name to timepass2, and I want to change DOB to DOB2 on this line. On the line below that, I'll print timepass2. For the duration name, I'll make that time since 2. On the next line, I'll change that from DOB to DOB2. And lastly, I'll print time since 2. Now, running this, Notice that this second kid was born on Cinco de Mayo in year 2022 at 7:15:37 a.m. This is local time, so it's LA time for us. Now look at the period. I'm seeing 4 months and 4 days there and 52 years in that output. For the duration, I've got more hours, but you can see there's 15 minutes and 37 seconds there as well. In addition to the between method on the duration and period classes, there's a between method on the chrono unit enum. I'll show you this by looping through all the values in this enum. You can only use this method for a temporal class where it makes sense. In this case, I'm testing data between two local dates, so I can use the isSupported_by method on the enum to see if the chrono unit makes sense for this class. If they're not supported, I'll print them out so you can see which aren't supported by a local date in this case. The between method always returns a long. I'll call the between method on U, passing local date.epoch with dob2.localDate to do a comparison. I'll print the enum value and the result of the between call. In the case of it not being supported, I'll print a message indicating that. Running this code, you can see that the clock-based chrono units, nanos, micros, millis, seconds and so on aren't supported for a local date time. I can use this. However, to get days elapsed, months, years and decades as well as centuries and millennia on a local date class. I'm going to Control-click on chrono unit to bring up that enum in an IntelliJ tab. You can see that this enum has a constructor that takes two values, the first a string, and that's what gets printed out. The second is a duration created using the ofFactory method, each with a different numeric literal passed in. These are described in the comments above each. You can't use this enums method on an instant, but you can use it on a local date time. I'll create a new local date time for the epoch using the ofInstant method, passing that instant.epoch and the UTC zone offset. I'll copy that for loop and paste that after the LDT declaration. I'll change local date.epoch to LDT. I'll change dob2 to local date, removing the method call on the next line. In this case, I'm passing a local datetime instance to this method, so let's run it and see what we get. Now you can see that all of these chrono units are supported if you want to use them on a local date time. There are many other features on the java.time packages, and I encourage you to read Java's API. I believe I've covered many of the most commonly used ways you'll use these classes, and I'll be coming back to these classes often. I'm going to end this video here. In the next video, I'll be talking about the principles of localization, which customizes a user's experience to their regional language. See you in the next video.